Hello everyone. Let's see C interview question. What is the difference between structure and union? In C, structures and unions are both used to group different types of variables under a single name, but they differ in how they store and manage memory. So, structure, in simple terms, we can say memory is allocated for all the fields. For example, there is a structure have the fields like int id float marks char grade, so the memory is allocated for each fields. So that is the difference between structure and for a union we have the fields like same fields, but it will allocate a memory for which has the highest memory. So total if the size of the integer is 4 bytes and the float also 4 bytes and char 1 byte, so totally it allocate for the highest memory which has the highest memory in union. So it will total size will be 4 byte. 4 byte is higher here when compared to char 1 byte. So in union it will allocate a single field memory which has the highest memory space. So the key difference is like in structure allocates a separate memory for each member in a structure. So size will be total size is the sum of all members. Useful when all members need to store a unique values. In union memory allocation, all members share the same memory space. Size is equal to the largest memory member size, and then useful when only one member is needed at a time. So this is the key difference between the structure and the union. Let's see what is structure padding and why we need to use it. Structure padding is the automatic addition of extra bytes by the compiler between structure members to align data in memory efficiently. This ensures that data is accessed faster. So why we need the structure padding means to avoid the unaligned memory access. So for example, if we are storing character 1 byte first and then we are storing the 4 byte value. So now the memory will be unaligned. Let me show. So if we are storing a character variable a, it takes only 1 byte, and then we are storing the integer which will take the 3 bytes, and then it will store the another 1 byte in a separate memory location. So it will be not it is unaligned memory access. So this is called unaligned memory we are accessing. So to avoid this unaligned memory access we use the structure padding. So instead of we have to use instead of using this 3 bytes here, you can use the 4 bytes whole here fully. So this space is empty, right? Here we are used to pad this space. So using structure padding we pad this space to avoid the unaligned memory access. Why? Because unaligned memory access leads to a more CPU cycle. So this is what we are using unaligned to avoid unaligned memory access. We are using structure padding. Let's see what is a storage class and its uses. Storage class in C defines the scope, lifetime, and then memory location and default value of a variable. So it determines how the memory is allocated for a variable and whether its value passes between function calls. So types of storage classes are, there are four main storage classes in C: auto, register, static, and extern. Auto means automatic storage class. it has the scope of local to the block, local to the function or block where it's declared. Its lifetime is created when the function is called and destroyed when it exists. Memory location is it is stored in the stack. So default value is a garbage value. And then register storage class. So its scope is it is local to the block as a automatic. Um, and then its lifetime is created at function call and restored when it exists. Memory location is stored in a CPU register if available, otherwise in a RAM. And then its default value is a garbage value. And then a static storage class. Static storage class scope is a local, local or global. Local means if declared inside a function, or global if outside. And then its lifetime is throughout the program. And then its memory location is data segment. Its garbage value is 0. And then for extern storage class used to extend storage class scope is global, accessible across multiple files, and then its lifetime is throughout the program, and its memory location is data segment, and its garbage value, its default value is it's stored as a 0. So using extend, we can access the global variables that is declared in the another file. That's why what is the usage of extend. And then another usage of static is it will retain the value between function calls. It is global, but limited to that file itself. Let's see what is the difference between array and linked list and when it used. So difference between array and linked list. Memory location is for an array is contiguous fixed size, and then for the linked list it's a dynamic, it's a variable size. So insertion deletion complexity is for the array is order of n due to shifting, and for the linked list it is efficient order of 1. Access time for the array is fast because we are accessing via index. So for the linked list it is accessing time is slow. We are because we are traversing uh, without an index, so it is slow. For a memory usage for the array, less overhead, only elements stored. And then for linked list is more overhead, extra pointers stored. And then resizing requires creating a new array for the array, and then for linked list easily grows dynamically. Implementation is built-in support in C, but for the linked list needs custom implementation. So when to use an array is fast random access needed. If a fast random access needed for order of 1, we use array. Fixed size data means storing student marks. Limited size means we use an array. And then when to use a linked list is frequent insertion deletions, or example implementing a queue stack. In that case we use a linked list. Unknown or changing size, we don't know when we don't know the size. Dynamic data structures like example graphs, we use a linked list. Less memory fragmentation. And then when we avoid it, it means if the random access order of 1 is needed, we avoid a linked list. So this is the key difference between array and linked list. What is the difference between thread and processes? So key differences between these two is for a memory, a process has its own memory space, but while threads share the same memory within a process. Communication, for a communication process require inter-process communication, whereas thread communicate easily by sharing memory. And then for a context switching, switching between processes is slower than switching between threads. For an isolation, processes are independent, while threads within the same process can affect each other. Creation overhead. Creating a process is resource intensive, whereas creating a thread is lightweight. Crash impact. A process crash does not affect others, but a thread crash can impact the entire process. So its use cases, processes run separate application while threads handle parallel tasks within a single application.